In section 3.3, we talk about graphs and the equations of a line. So the first thing is slope-intercept form. So the slope-intercept form of an equation of a line is y equals mx plus b. And so m is the slope and 0b is the y-intercept. So when we graph a linear equation in slope-intercept form, the first thing we do is plot the y-intercept. Then we're going to write the slope as a fraction, and going from the y-intercept, we'll use the rise over run to obtain a second point. Once we have the 2 points, we can connect these with a straight line and put arrows at the ends of the line. So we have 28x minus 7y equals 21. We need to find the slope and the y-intercept and then sketch the graph of the equation. So we need to solve for y. So let's go ahead and subtract 28x from both sides. And so it cancels on the left, and we have negative 7y equals negative 28x plus 21. And to get y by itself, we're going to divide everything by negative 7. And so it ends up canceling on the left, and we get y equals negative 28 divided by negative 7 is positive 4, and 21 divided by negative 7 is negative 3. And so my slope is 4, or we can write this as 4 over 1, and my y-intercept is the point 0, negative 3. And so to plot this, the first thing we do is we plot the y-intercept. So let's go ahead and plot 0, negative 3 first. And then from here, we're going to use the slope, which is 4 over 1, to plot the next point. So what this is saying is we could go up 4 units in the positive direction, and we can go right 1 unit in the positive direction. Or, let's just remember, we can always write 4 as negative 4 over negative 1, because this will still give me a positive 4. So we have another direction that we can use. We could go down 4 units and to the left 1 unit. Either one will put you on the exact same line. So I'm going to show you both directions just so that you're aware of it. So we're going to go up 4 units, and then we go to the right 1 unit. That's one direction, and I'll be off my graph just a little bit, but we could also go down 4 units into the left 1 direction. And so you can see that this would still fall on the same line, no matter which way I went. Now we have another form, which is the point-slope form. And so the point-slope form of the equation of a line is y minus y1 equals m times x minus x1, where m is still the slope and x1, y1 are the coordinates of a known point on the line. So if I'm graphing a linear equation in point-slope form, the first thing I'm going to do is I'm going to convert it to slope-intercept form. Then I'm just going to do the steps that we did for example number 1. So we need to find an equation of the line that passes through the point 3, -2 and 5, 1. We express our answer in slope-intercept form and then sketch the graph of the equation. So the first thing we need to do is find the slope. So writing down our slope formula, we got y2 minus y1 over x2 minus x1. I'm going to label my points. And so y2 minus y1 is going to be 1 minus -2. And then in the denominator, we've got x2 minus x1. Well, x2 is 5, and x1 is 3. And so on the top, I have a double negative, which turns into 1 plus 2. And 5 minus 3 is just 2. And so we end up with 3 over 2. Now, when picking a point to plug it into point-slope form, it does not matter which one you pick, because when you simplify, you'll get the exact same answer. So I am going to just use the 3, -2 that's labeled as x1, y1 to plug into our formula. And so we're plugging into point-slope form. And so y1 is -2. Our slope was 3/2, that's what we just found. And our x1 is 3. And so we want to now manipulate this and put it into slope-intercept form, where it's just y equals mx plus b. So the first thing I'm going to do is I'm just going to simplify the double negatives. So we have y plus 2. And then I want to go ahead and distribute my slope to both points, or both numbers. So we have 3/2 times x, or 3/2 x, minus 3/2 times 3. Well, when we multiply with fractions, we multiply across the top and bottom. And so what we end up with is y plus 2 equals 3/2 x minus 9 over 2. And then the last step is let's go ahead and subtract 2 from both sides. And so we have y equals 3/2 x minus 9 over 2. And then we have a minus 2. But we need to have a common denominator to combine these terms. And so I'm just going to write this over 1 and make my common denominator 2. So I need to multiply this by 2 on the bottom and 2 on the top. So we end up with y equals 3/2 x minus 9/2 minus 4 over 2. But -9 minus 4 is -13. And so we end up with y equals 3/2 x minus 13/2. And so let's talk about what the y-intercept is, because that's the first thing that we need to plot. And so my y-intercept would be 0, -3/2. I'm sorry, 0, -13/2. Or we can do this is going to be 0 and -6.5, -6.5. And my slope is still 3/2. And so that means that I can go up 3 units and to the right 2 units. Or remember, we have 2 options. We can go down 3 units and to the left 2 units. So let's go ahead and plot my y-intercept first. We've got -3/2, which is going to be -6.5. So let's go ahead and just estimate it right about there. And then we're going to go up 3 units and to the right 2. So we've got 1, 2, 3, to the right 2. And we've got one more form we need to talk about, and that is standard form. We don't use this that often because we can't tell a lot of information from it. But the standard form of the equation of a line is ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. So let's go ahead and find an equation of the line passing through the point -2, -4, and parallel to the line 2x plus 5y equals 8. We're going to express the answer in standard form. So the first thing we need to do is we need to look at the line 2x plus 5y equals 8 and figure out the slope. So I'm going to go ahead and turn this into slope-intercept form. So I'm going to subtract 2x from both sides. So it cancels on the left. And we get 5y equals -2x plus 8. And then we just need to divide everything by 5. And so we end up with y equals -2/5 x plus 8/5. And that means that the slope of this line is -2/5. And we know that parallel lines have the exact same slope. So that means that the slope of my parallel line is also going to be -2/5. Well, now that I have my slope, I have my new point, which is -2, -4, and we can plug this into point slope form, which is y minus y1 equals m times x minus x1. We've got our x1, y1 over here, and we have our slope we just found. So we have y minus -4 equals our slope is negative 2/5. Times x minus, we've got negative 2 as my x1. And we want to put this into standard form. So what I'm going to do is I'm going to simplify my double negatives. We've got y plus 4 equals negative 2/5 times x plus 2. And so let's go ahead and distribute the negative 2/5. We've got y plus 4 equals negative 2/5 x. And then negative 2/5 times 2 is going to give me negative 4/5. Now we want to make sure that we get rid of the fractions. So we are going to multiply this entire thing by 5 so that we can get rid of the fractions. And so we end up with 5 times y plus 5 times 4 equals 5 times negative 2/5 x minus 5 times 4/5. And so what ends up happening is the 5s are going to cancel in the fractions, and we are left with 5y plus 20 equals negative 2x minus 4. We need to get x and y on one side, so I'm going to add 2x to both sides. And so it ends up canceling on the right-hand side. We get 2x plus 5y plus 20 equals negative 4. And we need to just have the constants all on one side. So I'm going to subtract 20 from both sides. And we have 2x plus 5y equals negative 24. And that is standard form. And the last one, let's find an equation of the line that passes through the point 2, negative 3 and is perpendicular to the line 3x minus y equals negative 12. We're going to express this answer in standard form. So we're going to start this just like we did in example number 3. We need to find out the slope of 3x minus y equals negative 12 first. And so I'm going to put this into slope-intercept form. And so I'm going to subtract 3x from both sides. And so we end up with negative y equals negative 3x minus 12. And to get y by itself, we're just going to divide everything by negative 1. So we get y equals 3x plus 12. And so the slope of this line is 3 over 1. And we want to find the perpendicular slope, which is the opposite reciprocal. So this is going to become negative, and we're going to flip the fraction. And so my new slope is going to be negative 1/3. Again, we're going to plug this into point slope form. We have our point, which is 2, negative 3, and we have our slope that we just found, which is negative 1/3. And so plugging this in, we've got y minus negative 3 equals negative 1/3 times x minus 2. And so I'm going to get rid of my double negative again. So we got y plus 3 equals negative 1/3 times x minus 2. Let's go ahead and distribute the negative 1/3. So I get y plus 3 is negative 1/3 x. And then negative 1/3 times negative 2 is going to give me plus 2/3. And so we want to multiply everything by 3 so that I can get rid of the denominators. And so what we end up getting is 3 times y plus 3 times 3 equals 3 times negative 1/3, negative 1/3 x, and then we get 3 times 2/3. And so on the right hand side, the 3's are going to cancel, and what we end up with is 3y plus 9 equals negative x plus 2. We want to make sure we get x and y on the same side, so I'm going to add x to both sides. So we have x plus 3y plus 9 equals 2. And we just need to get the constants all on one side. So we're going to subtract 9 from both sides. And we end up with x plus 3y equals negative 7.